In today's tutorial, we are going to have a look at ortho and paraquinonoid structures. How are those highly reactive species generated and how do they react in general? So for the parent orthoquinonoid compound, we can start with ortho-bis-bromomethylbenzene. The highly reactive species, the orthoquinonoid structure is this one. How can we generate that from here? Well, we have to eliminate bromine. This is easily done by a monometallation, for instance, with magnesium. As soon as we have a Grignard structure here with a magnesium, so a benzyl magnesium bromide here, then magnesium dibromide will eliminate, giving rise to this non-aromatic structure. The same method applied for the para-substituted system. So one equivalent magnesium and magnesium dibromide eliminated will give rise to the para-substituted congener, this one. How do those react? For instance, by polymerization, or if one has another reagent that can be added. But just even at low temperatures, with no other reagent present, this will react with a second molecule of itself, preferentially undergoing a Diels-Alder reaction, because always it wants to have its aromaticity restored. And with the Diels-Alder reaction with the second molecule, for one six-membered ring, this is successful. The other one is annihilated as a spirocycle with still an exomethylene group. So this is the Diels-Alder product of two molecules of this. These, the paraquinonoid structure, can also dimerize to an interesting compound, the 2,2-paracyclophane. Let's draw it. Two of those benzene rings are above each other, clamped together by two ethane diol bridges. An especially elegant route to structures like that was invented by Professor Hopf 50 years ago. He started from this bisalene and with an alkyne substituted by electron withdrawing groups, that it becomes a good electron poor dienophile. This will undergo a Diels-Alder reaction with that part of the molecule, a diene, resulting in indeed a paraquinonoid compound. And this can dimerize to a 2,2-paracyclophane. So this should be the front part on the one hand, and here we have also two of those, for instance, ester functionalities. So the two benzene rings are above each other. Two of the ester groups are pointing in one direction, and two of those ester groups are pointing into the other direction. Thanks for listening. I forgot. This structure is formed in up to 32%. A moderate yield, but an extremely short synthesis for paracyclophanes.